So I see that you created some shapes, and then you also have drawn outline or rectangular shapes. Now, do these represent your sheets, or can you explain to me a little bit about what these represent?
Yeah, those are the sheets that I use it just to give an idea how much material we need.
Okay.
And that's what they are. So you can delete all that if you don't need it there.
This one right here?
Yeah, that one too. Yeah, that's just a little garbage that done from copying the file.
So these are the parts that you're looking to cut, nest them into a sheet and machine it?
That's correct.
Okay. All right. Now, did you manually put them into a sheet, or how did you go about creating these?
I manually put them there.
Okay. All right. Okay. And I can see here that part of the geometry here is going past your sheet extent, as you see right here.
Yeah.
Okay. All right. So would you like to nest these parts into a sheet before you generate G-code for it?
Yes, please.
Okay. All right. So one of the things we could do here is I'm going to go ahead and look at the layers, and it looks like you've defined one that's called plates. I'm just going to hide them all together, okay?
Mm-hmm.
And before we nest the parts, we need to make sure that the exterior shape is a closed curve. So it looks like you have, some of these exterior shapes that you have on a layer that's called cut right here, right?
Yes.
So if I do select objects, it select all the objects inside here. And I need to first chain or join them together in Rhino. So I'm going to exclude this particular line segment in here, okay?
Yeah.
And I have these shapes selected, and I'm going to do a merge or join in Rhino. So it says 654 curves joined into 33 closed and 14 open curves. So it looks like we have a bunch of open curves in here. So let's go ahead and identify the open curves. Okay? Yep. So let's go ahead and do a select open. All right. So we have a few open curves in here. These ones right here, right, as you see them?
Yep.
Okay, so we need to make sure these are also closed if you want to nest them together.
Okay.
Okay? So I'm going to select and join these. Okay, here I'm getting a message saying unable to join the curves. So let's see if there are any duplicates or what the issue with these curves are. Right? Typically, you want to have them join. It says 5 curves joined to 1 closed and 3 open curves. So it looks
Might
like
be a
there's
duplicate.
Yep, there could be a duplicate. You're right. So I'm going to go ahead and select, try and explode these in here.
Yep.
Okay, so it's exploding into 184 segments. Okay, there's a duplicate right here. You see that, sir?
Yes.
So you got to fix those duplicate in here. You can even try select duplicate. You can see the duplicated objects are being selected. Now I deleted them in Rhino. So now let's go back and try and join these together. It says join to 2 open curves. So it looks like, again, we have some sort of an issue here. Right? So let's go back in here and explode this. Okay, we found a duplicate right there as well. So let's see if now it'll resolve this here. Okay, it says 1 open curve. You may have to explode this too. So you have multiple duplicates in there. So now it's joined to an open curve again. Let's try doing a closed curve. So it's closed it by adding a line segment. So anytime you need to nest, you need to make sure the exterior shapes are closed. The internal ones can be open. So now let's look at these ones here. This is okay. Now we just need to look at...
You can delete that one.
Sorry, sir, go ahead.
Yeah, you can delete the line by itself.
Okay. So you no longer need
Yeah,
this line. I can
yeah, that
delete it.
line. Yeah, you
Okay.
can delete that one.
Okay. So let's try select open curve. So it's still adding 4 of these curves, as you see right here, right?
Yes.
So it looks like there's some issue, maybe some duplicates. So you got to go ahead and fix those duplicate geometries. So I'm just basically trying to merge. You can see there's a gap right there. We'll have to fix that in Rhino. So these are basic curve editing that you may have to do in Rhino to fix them.
Yes.
Okay, I'll join this together. It says join to 2 open curves. Okay, 1 open curve. So it looks like we have a little gap in here, right?
Yeah, it's up there. You can join it with a line, or you can extend that one to there.
Yep, I can do a line here. Okay, would that be good for now? All right.
Yeah.
So let's go ahead and check again for open curves. So what we are doing right now is still, you can see again you have some issues in here, right?
Yes. You can see those verticals are probably double lines.
Yep. So I just did a close curve command in Rhino to close it. So now if you do a select open curve command in Rhino again, okay, it's still finding an open curve right here. Okay, this is the one.
You can delete that one, yeah.
Okay. For now, we'll just clear it out. Okay. All right.
Yes.
So let me go back and make these layers visible here. You had some inside scribe lines or maybe some markers in here, right?
Yes.
Okay. So here's what we're going to do now. We want to nest these into a sheet. So we need to know the sheet size. It looks like you had some rectangular shapes in here. I can take a measurement on one of these, analyze distance. So that's about 300 inches by 72 inches. Is that correct?
Let's do 20 by 6.
Okay. So what I'll do is I'll take all of
20,
these.
20 by 5. 20 by 5, sorry.
Okay, so it's going to be 20 inches long by 5 inches wide?
No, 20 feet long by 5 feet wide.
Okay, all right. So here's what I'm going to do. Just to make it easier, I will move these closer to the origin.
Yes.
Okay? I'll move a point right here. I'll say move that to 0. So we'll just place it closer to the origin right there. Okay?
Okay.
And looks like they're all in one plane, so which is good. So now I'll make a new layer just to define our sheet. And you said you want to go, the sheet size, you want it to go 20 feet. Would it be on the X or would it be on the Y?
On the X.
Okay, so 20 times 12 is 240. Then 5 times 12 is 60. So that would be the sheet size we created. I'm going to go to the nest module. We'll pick true shape nesting. We're going to use select sheets, and we can say select the curve. I'll pick this as the sheet, and then I can specify a thickness or quantity of the sheet. We can do that later. We'll go back into the parts to be nested, and I can click on select parts. I can do a window selection here, select all of these as the parts, okay?
Okay.
And then once you make a selection, you press right-click to accept it. And now since you have, open lines, open curves in here, they're going to be treated as separate parts here. So in order to treat them, everything inside the exterior boundary is one, we use this checkbox in here called use for sign making and engraving. So it's going to group everything inside the exterior shape as one part. So right now we are down to like 33 parts, as you see right here. So if I pick this, it'll highlight the corresponding geometry for you. Okay?
Okay.
And if you go select one of these here, you'll notice that this is treated as one part, and everything inside that is treated as a child to the parent. Okay?
Yes.
So it'll maintain the same topology, and it'll maintain the same features for you. The relationship will be the same when you select use for engraving and sign making, it's going to treat everything inside the exterior shape as one component or one part. Okay? So the next step is basically to specify the orientation step. So you could choose any orientation. So I can leave it as 90, or you can choose 45. So any orientation of 45 degrees you can use to fit the parts into the sheet. And then you specify the nesting parameters. So this would be the distance between adjacent parts. What is the minimum distance you would like to maintain between each part based on the size of the tool that you're going to be using for it, right?
Correct.
So if you're going to be using a half-an-inch router bit to cut it, then I would leave at least a minimum half an inch, or I could say maybe 0.6, for example, right?
Okay.
And then distance from the edge of the sheet to the part, you know, it could be as little as 100 thousandths or 50 thousandths, the minimum distance, so you don't have a factory edge being left.
1 inch is going to be.
From the edge of the sheet, you want to leave 1 inch around, all the way around?
1 inch.
1 inch, okay. And now if I pick estimate number of sheets, the system will automatically determine how many sheets you will need to basically fit all of these parts. So right now we have an estimate of 5 sheets. If you need one of each part to be fitted into the sheet, you need a total of 5 sheets. I'm going to update the sheet. Now I'm going to choose Execute Nest. So in this process, it's going to find the best optimal solution to fit the parts into your sheet. So it's computing, and you will notice that if any of the parts were not nested, it's going to identify them here. So this line was not nested, so it'll identify the parts that were not nested in here. You can see right there. So if they're self-intersecting or if they're right on the edge, it'll fail to nest those parts right in here as you see it. Okay? And also, this part, it failed to nest, so maybe it was not a closed or there was some issue with the part. Okay?
Okay.
So it tells you the parts that failed to nest in here. And we can go back and take a look and see, or we can, fix geometries. But here you can see that, the process of nesting right in here. Okay?
Perfect.
So once it's nested, you go down to, it says Commit Nest. You can say create a separate layer for each nested sheet. And then you can do a Commit Nest. It's going to create 4, or in this case 5 sheets, and they're stacked right on top of one another. So I can basically, you can see I'm hiding the, the layers in here. So you have your first sheet, your second sheet, sheet number 3, sheet 4, and then sheet 5. Okay?
Okay.
So let's consider the first sheet in here, right? Any questions so far?
No, it's pretty good, pretty explanatory.
Okay. Now we can also export. We could have exported these as separate files. We could have done that as well. So for example, if I go back in here to when I do Execute Nest, so after executing the nest, I can go down here to Commit Nest. Instead of outputting it in the same file, I can specify a path where I want to export this to. And for example, I could say I want to put it on my desktop. I will create a new folder. Okay. I'll select this. And then when I pick Export, it's going to export these to the folder I chose. So if I go to my desktop, I will be able to see the sheets I just exported right here.
Oh, okay.
Yes, sir. So I exported each sheet to a separate Rhino 3DM file. Now let's go ahead and instead of exporting it here, into the same file, you can export them each sheet to a separate file. Now let me go ahead and save this out. So I'm going to do a save, or I could do a save as. I'll just call it Test 1, Revision 1. Okay? So let me go ahead and open up the first file. So this is the first file right in here. As you see, we have the first sheet, right? Sheet of parts.
Yep.
We're now ready to program toolpaths for each of these. So we switch from the nesting module to the mill module. We are now ready to define the machining process. So we go to the program tab. So for 2 and 3 axis machining, we'll pick 3 axis. The next step is to select the post processor. So this depends on what machine tool you're planning to write the G-code output for.
It's a multicam brand.
Okay, so we do have posts for multicam in here. So I will pick the multicam post right down the list. You can see there's some multicam. I'll pick the inch right here. Okay?
Yeah.
And multicam can read .nc or .cnc files extension. So I can type the extension as .cnc for multicam.
Okay.
And in the next step, we are ready to define the stock. So as you notice here, as we define the machine and the post, these information are updated under the machining job. The next step is to define the stock. We'll choose stock and box stock, and you'll notice that the system automatically computes the extents of the stock, length, width, and you put in the thickness of the material that you're going to be using, 1/2 inch, 3/4, whatever the thickness is going to be.
1/4.
1/4, so 1.25, right?
0.25.
Oh, you just said quarter. Okay, I thought it's 1 1/4, so 0.25. Okay, I apologize.
Yeah.
Okay.
No
So
worries.
we define the sheet, and the next step is to align the sheet. So we do align stock. So we are aligning the stock so the stock is flush to the top of your drawing. And then you can specify the location of your XYZ origin. So you can use, by default right now it's set to the lower left corner and the top of your material. If you need to rotate the part and the sheet to fit the work envelope, if you have more travel on the Y compared to the X, then we need to rotate it. But if this orientation looks correct, we can just leave it the way it is and then define the work 0. So this is the location where you want to put your origin. Do you want to put it to the southwest corner, which is the lower left corner, or you want to pick a different location? You can choose where you want to put the origin to for machining, your XYZ 0, right?
Right.
So we're going to leave it at southwest corner and then top of the material for the location of 0, 0, 0. So you're going to be doing the touch off on the top right here, okay?
Okay.
Now we are ready to create some machining operations. So we could define tools, or we can have a library of tools loaded. As you can see here, I have a library of tools loaded. I can pick from one of these tools. I could also make changes to the parameters that are loaded. I have a tool defined. My feeds and speeds are also set. I can always change the feeds and speeds parameters depending on the material that you're working with. So for example, if the material of the tool is going to be carbide, so I can change it to carbide. Go to your feeds and speeds, use load from file, and you can specify your spindle RPM that you want to run it at. I could say I want to go at 15,000 RPM, and this will recompute the cut feed rate. If you want to slow it down, I can always change the cut feed rate and update all of this information and save it as a tool. Okay?
Okay, yep.
So we want to first cut the profiles. We'll do 2-axis profiling. And now we're going to select the shapes for profiling. So I'm going to click on Select Curve Edge Region. I can select each of these curves individually, or in Rhino, I can say Select by color and pick one of these shapes, and the system will automatically pick all objects of the same color, and then right-click to accept your selections. So we have 7 geometries of a color red. You select a tool, you set your feed speeds, your clearance is set to automatic. In the cut parameters, you can choose your cut direction, your cut side to cut outside or inside. And then you specify your depth in here and the cut level, so you can specify how deep you want it to cut. So it's going to be 1/4 inch, or if you want to go slightly deeper into your spoil board, I can say 0.26, for example.
Yep.
And you can break this up into multiple Z levels passes. You could say, or you just want to take it out in one step, you can say 0.26 in one step. You can control your entry and exit, where you can ramp along the path. You can specify a ramp height. Retract can be set to none. You can also fit true arcs to your tool paths, and you can sort them So it goes, use this minimum distance sorting, so it makes it much more efficient as you're cutting it. And then selecting generate creates your toolpath. So there's your profiling operation in here. And let's
okay,
run a simulation. You can select the operation and click on play, and you'll notice your cut material simulation. And as you can see, it's going all the way through to the bottom. And you can always speed up the simulation at any time. Do you have any questions, sir?
No, it's been pretty good, really good.
Okay, so we just programmed the profile in here. The next step we want to do is program these in here as well, right? The inside components?
Yes.
So do you want to just basically scribe on top of it, like have the cutter follow the center line on this?
Yes, we can do that.
And how about these ones here?
Same. Just scribe them. Yeah.
Okay. So we'll do what's called engraving, so the cutter will stay on it. So we'll pick engraving. And again, you can select the curves. I can use by color, and I can just grab one of these. It automatically selects all of these geometries for us. And then I can pick a tool. Would you want to use like an end mill, like an engraving bit, like a V bit? Or what type of tool would you like to use for it, sir?
I think the engraving will be the one to use on that one, isn't it?
Okay. So, yep, we can do an engraving, a 45-degree engraver. We'll pick that. And then you can set your feet and speeds. You can set the clearance. And then cutting, how deep you want it to cut. Maybe 50 thousandths, 100 thousandths, how deep those cuts are.
Yeah, the minimum one, just in order to see it.
Okay, so we'll probably do, 25 thousandths deep, right?
Yes.
And then we'll apply a sorting, generate. I'm going to go into the Simulate tab and run a cut material simulation. You can see it shows the scribing operations for you, or engraving with a V-bit. Okay?
Now, Uday, what happened if we wanted to use a marker instead of engraving?
You could put in any tool that you like over there. So engraving just basically follows the center line. I just use an engraving bit, but you can put in any tool of your choice to cut it. Okay. Now that we programmed this, now ideally the way I would want to do is do the engraving first before we cut it out, because the piece would still be intact with the stock. So I'm going to reorder it. So have the engraving done first. So you can just do a simple drag and drop, so you can engrave it first, and then go back and do the profiling on the part. Now, if you like to do bridges and tabs, we do have an option to do bridges and tabs. If it's not vacuum held and you wanted to, leave some tabs, we can define bridges and tabs as well. Okay?
Okay.
So now that we have programmed this, we can take a look at the estimated time. Right-click information will tell us how long it's going to take to cut it, if you're cutting it 150 inches per minute for the sheet number 1. And now you want to generate a G-code, right-click and post. And this creates your G-code output for your multicam CNC, and it's ready to be transferred out to the machine tool. Now that we have programmed one of these parts, we still have 4 more sheets that needs to be programmed. So what I'm going to do here is save these operation workflow into a knowledge base. Like it would be like a template of operations. I'm going to select save and save this out. Okay?
Yeah.
So now that I've saved the workflow, I'm also going to go ahead and hit save to save this file. I'll just say sheet 1 of 1 completed. Okay? The next thing I'm going to do is load my sheet number 2. So we still need to program these sheets here, right?
Yeah.
So I loaded the sheet 2. It looks very similar to sheet 1, but the parts could be of different shapes. So rather than having to go through the process of recreating toolpaths by selecting the 2-axis engraving or 2-axis profiling and having to select the geometries, we can now load the operations we saved into a knowledge base. I'm going to click Load Knowledge Base. I'm going to pick the sheet number 1, and you'll notice that the knowledge base already contains or includes the 2 operations. So it has information about your tool that you selected, has information about your feed speeds, as well as the cutting parameters, like how deep you want it to cut for each of the operations. So the knowledge base has the intelligence built into it, right? So now all I'm going to do is define my stock in here, okay?
Yep.
And once I define the stock, I just have to go back in here and generate each of the operations. So for the engraving, I'll have to select curve edge regions and then select the curves of this particular color, right? And then generate it. Repeat the same process for the profiling. Select the curves of color red, select it, generate it. And now we have the toolpath generated. I'm going to run a simulation. So you can see that in just a couple of minutes, we were able to reuse the same operations on the second part. Okay?
Okay. Yeah.
So by using knowledge bases, you can automate your programming workflow. Now, what we did here was we loaded the knowledge base, and then we had to edit each operation and select the geometries for machining. Now, we could go even one step further. So I'm going to go ahead and save this out. I'll call it Sheet 2 completed. Okay? Now, I'm going to go back and load sheet number 3 here. All right? So the sheet number 3 has a different set of geometries in here, right?
Yes.
Okay. Now, what I'm going to do here is, rather than having to load the knowledge base and then having to pick each of the geometries, we'll automate a few steps in here. So I'm going to go ahead and select the Knowledge Bases tab. I'm going to load the knowledge base right in here, and then I'm going to set some rules. So for the engraving, I'm going to double-click and say Apply Rules and pick automatically select objects of a certain color. So I'll pick this color. And then for the profiling, I'm going to set it to automatically select objects of a certain color. I'll pick this color red. Okay? So now I have established rules to the knowledge base, and I'm going to go back and save this out to a knowledge base as well. I'll call it with rules. So now that we have established the rules, I'm going to open the knowledge base or load the knowledge base. You will now notice that once I define my stock in here, all I have to do is right-click and regenerate, and the toolpaths were automatically generated, automatically selected the lines based on the rules that we put in, the geometries. So the knowledge base now has rules, selection rules, to automatically select geometries based on a color. We can also set rules based on layer or based on geometry type. We can do that. So this is how you can easily, establish rules and automate your workflow. So now when I do a post process, you have your posted output file right here.
Oh, wow. Yeah.
Any questions?
I guess the only question right now, Dave, will be, this has to be done sheet by sheet.
We can do all the sheets in one file too. You can just basically group them and then do it. And let me show you how that can be done. So let's go back and load the part we initially started with, right? The test 1.
Yes.
So here you can see each of the sheets are in different layers, right? Okay?
Okay.
So now when you have all of these objects, we can still apply the knowledge base here. I'm going to say load my knowledge base. So we have these 2 operations in here, right?
Correct.
So now what I'm going to do here is I'm going to put these into what is called a machining operation set. So I'm going to group them together. All right? So I can call this mop set for sheet 1. All right? Now, the next thing I will do is basically make a copy of this operation set, copy and paste. I'm going to change the name from sheet 1 to sheet 2. I'm going to hide the sheet 1 and make the sheet 2 visible. And I will go into this operation in here. Remove.
Do the pad again, okay?
Yep. Select curve region. I can apply it based on by color. Generate it. And then do the same. Remove it. Select curve edge region. And generate it. Okay? So I've programmed the second sheet. So likewise, I can keep programming each of the sheets, and you can have all of the sheets, programmed within the same Rhino file, and you can group all the operations into a mop set, which is like a machining operation set, like a container or folder. You can group them together. So now I can also make a copy of sheet 2 for sheet 3. I'm going to make the layer 3 active, hide the layer 2, edit the operation, select curves, generate, edit the profile, select curves, generate. Okay? So in this particular file, you can see there's curves that needs to be programmed on the inside versus the outside. So I'm going to make a copy of these, and then I can drop those curves that are programmed. I can say remove active. Remove active, I could do that. Or what I could do is we have a nice technique in here where we can go into the cut parameters and we can say alternate using nesting. So it knows if these are programmed on the outside, the ones on the circles need to be programmed on the inside. So you can alternate them automatically. And you can also have it cut the inside first before you cut the outside. Okay?
Okay, yeah.
So you have the option here to choose under sorting. You can say perform clustering, and it'll automatically cut the inside first before you do the outside. So you have these options under sorting as well.
Okay.
All right? So now we are automatically doing the inside. Oops, sorry. And then the outside. Any questions?
No, it's pretty good, pretty good.
Okay. So that's how you'd go about selecting each of these, and you can always go back and make changes if you need to, and then regenerate the toolpaths. So we now have programmed 3 sheets, sheets 1, 2, and 3. And if you'd like to output all of them into one file, you can do it, or you can just right-click on each mop set and post them out into separate NC files or CNC files. So you can automate your workflow by creating these knowledge bases. And you can save all of these to a knowledge base as well.
Okay.
So just to summarize, what we demoed today was RhinoCAM 2020, the NEST module, and the mill module. And all of this what we did was using our standard configuration, which includes the automation using knowledge bases. Nesting module comes included with it. So
yeah, no, that's perfect. That was amazing.
Okay. Any other questions I can help you here?
No, that was pretty good. That was well laid out. I mean, we basically gonna be newbies on this one. We're gonna start doing our own CNC here at in-house, so that give us a really good idea, And Rhino is one of the tools that we use, so that's why we're looking into the software.
Okay, great. So if you can give me one moment,